Ladies and gentlemen, welcome back to another live stream. So this is part 2 of this series of streams where I'm actually trying to implement Lua U scripting, Lua U JIT scripting into Bevy game engine. So Bevy game engine is like a Rust, is a game engine that is made in Rust and that uses WGPU. It's of course cross-platform, it's very modular, and of course open source. And Lua U is basically kind of like a version of Lua scripting language that is made by Roblox, that is more suitable for game development, that it have some more features like static type checking. It have more performance. It also have some more features like plus equal, minus equal for incrementing values and so on. It also have sandboxing. So that's just a lot of cool stuff. Anyways, please join my Discord server. You can find the link down in the description below. Let me just share the link real quick. Righty, let's go. One life. So of course, this project I'm working on right now is actually open source too. So let me pop out the chat, and there we go. So let's see, lab.com. I called it Kotaku Bevy Lua plugin. There we go. So this is it. Alright, so let's actually run and see what we have done so far. So basically we have a rotating script.lua here. And so if math.round, math.random01 equals 0, then x equal 1, else x equal -1. Here we got a function start, which runs at the start of the game engine or the game. So rotation script start, print self, and then here the update function, which rotates self with the vector where the y-axis is like x times delta time. Alright, so let's see what this actually does so far. So, and here, if we go back into the code, hold on, let me close the others here, and let's actually go to main RS. So this is the little example game, right? So as you can see, I'm actually attaching a script component to this camera and also to these two cubes right here. And of course here I'm loading the script, as you can see. So there we go. The camera is also rotating right now. Let's just remove that honestly, so we could focus on the cubes. Why not? Let's run again. So every time this rotating.lua would run for these two cubes because they have a script component, this script attached, and basically for every frame it will rotate it by x times delta time, where x is like the direction, and the direction is basically random. It's either left or right, you know, 1 or -1 randomly. So in this case, this is what we got, right? Cool. So that was just like the first thing. We have made it in 2 hours, and today hopefully we're gonna advance even more. Oh, by the way, let me actually share the stream in Bevy server too. Why not? That would be cool. Guess. Alright, let's go ahead. Bevy game engine. Streams. There we go. Alright, let's go. Okay, so what I want to do today, well, first of all, I want to clean up some stuff that we have done earlier in the plugin. So let's go ahead and do that, I guess. So mode RS. Alright, so this is what we got so far. Cool. Run scripts. So for example, here we have a star function, scope, So for example, this lua self, instead of putting it here, let's just to make it more clear, let's just actually construct it in place, because this is basically just being used here. So why have this whole scope right there? That's first thing, I guess. That's good. What else? I think the same thing here, probably. Here we go. Let's remove it from here. Let's just make it closer. It probably doesn't change any functionality, but it helps clean up the code. Here the update function doesn't have to be in the scope. The only thing that really we need the scope for is to create the user data and then call the update function, so we can make sure that the lua self only lives as long as this update function call. There we go. So that makes it more clear what's going on there. The other thing is, I would like to turn sandboxing on. I'm not exactly entirely sure what it does, but this is how you do it. So you just say sandbox, lua sandbox, and then you say true. So it sets all libraries to read only. It set all built-in metatables to read only. Set globals to read only. Activates save NV. Sets up local environment table that performs writes locally and proxies reads to global environment. So yeah. So we could just say true here when we want to actually call into the code, into the user code, and then we can turn it off when we're done. Because otherwise we cannot, like, if it's still turned on, we cannot actually mutate the state ourselves too. So yeah, use let to ignore the result. Yeah, this gives us a result. Hey Loop Luminary, welcome back to the live stream. In wrap, there we go. Lua.sandbox. So we turn on the sandbox, then we call the update function, then we turn off the sandbox. Perfect. We're gonna have to do the same thing with that other one. So here, we want to do it before we load the code, but after creating the environment, I think. So lua.sandbox.inwrap, and then I think lua.sandbox false here. So this shouldn't really change much. It would just turn on the sandbox mode for the user scripts. Hello, what are we doing today? Hey Hads, welcome back to the live stream. So I'm just improving the Lua plugin that we have made for Bevy game engine, pretty much. So we're basically this is part 2 of the previous stream, where we're creating Lua script, like we're integrating Lua U, which is Roblox Lua JIT, into Bevy game engine, basically. So that's what we're doing today. Alright, so sandbox false, sandbox true. So right now we have sandboxing on, which is amazing, perfect. Next up, so the next thing is I want to do something here. So first of all, I want to actually detach self from, but before that, actually I'm going to get these warnings function in used, function update is never used, prefix it with data silence, and that kind of annoying. So we could actually do it like this, you know, and then so make it, that's the actual name. Or like we could do like Godot, where they have like functions that start with these are basically reserved to the engine, I think, right? Isn't it? Godot engine ready, for example, node. So they have this ready callback. There we go. So all of these like callbacks of the engine, they start with this thing right here, which matches, which would also like fix that problem that the function seems to be in used, you know, to the list, like to the LSP that we're using, which is Lua language server, right? So that's a good double solution, I guess. Lua with Bevy, yeah, exactly. Lua U with Bevy. So Roblox Lua with Bevy. JIT even. JIT meaning that it's actually compiled like on the fly to actual binary code that can run on the CPU, which is very comparable to the speed of C. So you get like the good of both worlds, the compiled world and the interpreted world. That's basically it. Just curious, why would you do that? I guess for me it's fun, but there's a lot of people that would love to actually use Lua to script their games instead of Rust, you know, or C or C++. And that's one. And the other thing is the fact that changing anything in Bevy, like let's say you're making a Bevy game, right? And changing anything here in the Rust code, you would have to compile your whole game. And that would take quite a long time. But if you just use scripting, if you change anything in the script, not like you wouldn't need to like recompile anything. That's basically the reasons why. So yeah, cool. So let's actually change these names because we have changed them there. Let's go back to our plugin. We have the start function here. So right now it's going to be used like this. And where's the other one? The update should be like this. Perfect. Okay, so the next thing that I'd like to maybe fix is the fact that we have this errors right here because the LSP doesn't know that we have a vector here. So it would be complaining like that. And it doesn't know that we have a rotate function. It doesn't know what that rotate function. So basically it doesn't have any idea about the types of our stuff, right? About our own engine API. So how we can fix that? Well, it's actually not that hard. So if we go to Lua LSP, Lua language server GitHub. So what I've done basically, I've actually searched for definition files. So like if I go here and search for definition files. Whoops, definition files. There you go. And I found this one right here, documentation file contents for Lua LSP types definition files. So basically I'm showing you like the process on how I find stuff. For example, in this case, and there we go. I think this is probably the one who made this project now. Maybe some other one, not sure. Anyways, we have this gist right here. And if we check it out, we have an example of how we can actually make a definition file for the Lua LSP. Well, at least for this particular Lua LSP. I don't know about the other ones. Anyways, so this is how we do it. So let me first create this definition.d.lua here. And where I'm gonna put it, let's put it, I guess, in, I don't know, maybe here, definition.d.lua. Okay, or maybe we could put it in scripts. Yeah, okay, fine. Move. And the first thing that we need is, let's start with this vector, which is basically a global function. And so for a global function, what we do is, there we go, this is an example. Let's copy this example right here. And notice that luau actually have generics. So it does have some pretty good type checking system, right? Which I love. So, but in this case, we don't actually need it. So let's remove it. We're actually gonna go with number here. Well, basically we got X, Y, Z. So X, Y, and Z. And it would give us back a vector. Now we could just use vector 3. So that's fine. And then declare function, and this is basically vector, right? Now we created the definition file, but we actually have to give it to the LSP. So how are we gonna do that? Well, we're gonna go to settings, so preferences, settings, and we're actually gonna create a workspace setting, really, right? So we're gonna make sure to have workspace. So basically it would be configured only for this project right here. So type definition files. And so why I want to do that, because I want to push it into my GitHub repo. And so anyone who actually clones this thing and uses the same plugin as me, they would have this definition file set up already. So, and modified in user, well, let's just add item here, and let's actually copy the path to this. I hope we can actually use copy like relative path, but let's see. So I'm gonna say okay, and then let's reload the language server. And does it work now? Let's find out. Okay, it works, perfect. So right now, if you go to .vs code settings.json, you can see that it actually puts that setting right here, which is amazing. So now, if you hover over vector, you can see that it takes an X number, Y number, Z number, and it gives us back a vector 3, which is perfect. Now, it doesn't know anything about self and rotate, so let's add those two. Now, self in this case, well, honestly, in fact, before this, I want to actually change the design of this, because the thing is, if we'd like to allow the scripts to, you know, mutate or like to do stuff or to change stuff on other, like to call functions like rotate on other objects, like other than the actual object that they're attached to, we'll have to basically implement it on that too, which not gonna work out so well. So what I'm gonna do, basically, you're gonna understand, is I'm gonna have self just like as an entity, nothing crazy there, but I'm also gonna have an engine. So basically, instead of having, well, not engine, let's call it world, I guess. So basically, instead of having, where is it? Hold on, mod.rs. So currently, how I have it configured is that Lua self contains the world, the Bevy world, and also the entity. But I think I'm gonna actually like split them up from each other, so we could actually act on any entity. So the script can basically give us any entity, including self, but not limited to self. Hopefully that makes any sense. But you'll see how it goes. Anyways, so basically what's gonna happen here, you're gonna have world, rotate, and then you're gonna give the engine or the world which entity you're talking about, which entity you want to actually rotate, which is self in this case. Now this is kind of little, you know, not as beautiful as it was, but that's the way. Now we could indeed make a, like something like world get entity, you know, and then you would have entity being an OOP object, and then like let's say self, and then rotate and stuff. But I don't want to do that. I want to have the mutations only through the world, right? Through the world objects, because like if we create some other objects that have references to some other objects and stuff like that, it would be way harder for us to make sure that there is nothing wrong with, you know, mutations and references that are given to the scripting language. That's basically what my thoughts about this, right? So yeah, all right, cool. So self world, so self would be hopefully self, and or entity, actually self would be a type of entity, and then the world would be type of world, and then delta time would be type of number, pretty much. And what else? Self here would be an entity, but we also need the world here too. Now let's actually create definition files for these. So how do you actually declare a class? There we go. So this is how you do it. Okay, so declare class, example class. In our case, it's actually self. And this is how you create a method, apparently. Well, we are not going to have any methods, I think, in the... Well, yeah. At least for now, we're not going to have anything there, I believe. Yes. So just that, I think. Declare class self. And now we're going to declare class world, yeah. And now here, so example class method. So function, is it really function? No, that's not the way you do it. Oh, hold on. So this is a method. Rotate is a method. So let's actually put it there. So our function is called rotate, right? And then the first thing that it gets is the world, because this is a method. And methods in Lua are just regular functions that takes, you know, the first argument as the actual class object, right? So world, comma, and then we need a vector, right? So vector 3 in this case. And then what it returns nothing. This is the unit type in Lua. So yeah, declare class self. Now this should be good as long as I actually reload the language server of Lua. And now we should be good to go. Oh, a known type entity, huh? Yeah, I forgot about entity actually. Well, not self entity, my bad. All right, now let's try again. Control Shift P, reload. And there we go. Hold on, what's going on here? Type error, argument count mismatch. Expects 2 arguments, but 3 are specified. World rotate. Oh, I forgot the self or the entity that we want to rotate. So entity. Reload. And there we go. Now we don't have those errors anymore. We fixed all of those. Now we have the support of the Lua LSP. Perfect. Cool. Type world equal world number. Now let's say you actually made something wrong, like, you know, passed something other than the actual type. It's going to say type error, type number could not be converted into vector 3. There we go. Perfect. Now we actually have to code this into our engine because we haven't yet fixed that. And by the way, instead of this, I could just do it like this. Math.random, apparently, I actually forgot, but apparently when you give it integers instead of floats, what it does is that, like, it just gives you an integer back instead of a float, right? And also you can just give it 1 argument if you want, and if you give it 1 argument, that would be the maximum, and the minimum would be implicitly 1. So like instead of saying 1,2, I could just say 2, right? And then next up, so this would give me back either 1 or 2, right? And now I'm supposed to actually do something like this is equal to 1, right? But there is a Turner operators in Lua, so I could just say this and 1 or minus 1. And there we go, perfect. Now let's just rename this to something more rotation direction, I guess. And there we go. Pretty cool stuff. Lovely. All right, let's actually code our thing now. Let's go back to our plugin. And so how I'm gonna do this? Good question. So Lua self would only contain world, I think. And in fact, I'm gonna call it, instead of Lua self, I'm gonna call it Lua world. Shift F6. Oopsies, not that. I thought I was using Rust Rover. Oh boy, F2. Lua world. Whoops, world. There we go. So let's remove this entity from here. So we're basically separating the entity from the world. Perfect. So we could reuse the world for other entities. Basically, it's not attached to self. Right, perfect. Now where we're actually using this new function, we're using it here. So here we're not gonna have, oops, there we go. We're not gonna give it the entity. And so this is actually Lua world. Let's rename it to Lua world. And what else? Where were we using this again? Here. And there we go. Let's remove this entity here. And there we go. Let's actually rename this Lua World. Perfect. So now we also gotta pass in the entity. But before that, let's actually change something here. So we have a method mute rotate function, right? Currently it's only takes vector. But right now we actually made it take not just a vector, but also the entity you want to rotate. So let's change that. Let's fix that. So we're going to get the vector, but also the entity now. And of course, there should be a tuple. Okay. And so the entity would be, we could just say entity directly, like the Bevy entity. We don't have to do any abstraction, at least for now, I think. Could probably handle that. I mean, it's a copy function. It's just a lightweight identifier. So we'll see about that. Now we got this dot entity. Now we actually just get the entity directly from the function call. And what's next? That seems about right to me. To me. Now we actually gotta like give out the entity too. Now what I've done here is that I'm giving, hold on, the entity first, right? Or the world first, hold on. So self entity, then the world, okay. So self would be basically the entity. So can I actually do this? I think we would have a compile error because basically entity doesn't implement into Lua, I think. Into Lua, yeah. But we're gonna fix that in a second, hopefully. So entity, running entities, update.call. And here start.call. Here we're also gonna pass in the entity. And there we go. Now, so there we go, required for Bevy prelude entity to implement into Lua. Now the problem with this way of doing things is the fact that I can't actually implement user data. The user data for entity. And that's why I actually created a whole wrapper called Lua World, for the Bevy world, because I can't really implement user data on the world directly. And hello, Theo Barris, welcome back to the live stream. That's why I actually made this wrapper type. And so right here, I can't implement it. Only traits defined in the current crate can be implemented for types defined outside of the crate. So here we're dealing with the orphan rule. Luckily, I did find another way while I was, searching through the documentation and experimenting with the mlua library. I found a way to actually do that without having to make a new wrapper type if we really don't need that much advanced stuff. So let's go up to where we're creating the Lua state. There we go. So here's what I'm gonna do. So say.lua.register user data type. Right, and then what? Let's see. Register user data type. I actually forgot how to do this, apparently. User data, yeah, it's that one. And I feel like it's probably like you actually pass in the type here, I guess, if I remember. And there we go, right? This method takes one argument, but 0 arguments were supplied. So here it takes like some closure, apparently. And then what it gives me, what's the, so user data registry T. User data registry. Okay, so it's gonna give me some user data registry thing. Let's say registry, I guess. Okay, cool. And I guess maybe that's it. Yeah, I guess so. So does this work now? Good question. Let's see. Let's see. Oh, remove the extra argument. I see. So let's make these tuples, because the call function only takes one argument. Really? Let's also do the same thing for the other one. Well, it's already that way. So I guess it still doesn't work that way, right? Apparently. Oh, my bad. I forgot. We don't actually need that. That's just the way if we actually want to add some methods to the entity without implementing user data. So my bad, we actually don't need this, at least for now. What we actually need to do is go down here. And so lua self, let's actually call this lua self, and let lua self is equal to scope dot create any user data. Entity. Though honestly we don't need to make it in the scope. The entity, we could just clone it, I think. So what if we do it outside of the scope? Let lua self is equal to create user data entity. Well, we can't do this because entity doesn't implement user data, but if we actually do create any user data, then we can like pass it to to Lua as like an opaque user data type, right? So create any user data, and what this gives any user data, and then we can actually pass it here without any problems. There we go. Perfect. Yeah, let's actually do the same thing there. So here we go. Instead of entity, let's go with Lua self. And yeah, that seems about right. Let's see. Alright, so we have a little problem, which is here. Add methods mutable. So add method mute. The trait from Lua multi is not implemented for Bevy. So here basically we're trying to get the entity from Lua. So to actually be able to do that, we need the trait from Lua implemented on entity. Yikes. Yikes. I think honestly, probably just do the user data type thing. Call it a day. Or we could actually do it somehow like another way. But you know what? Like basically the other way is kind of like instead of entity you get like Lua value, right? I just wanted to show you this way of doing things. And then after that you just say let entity is equal to entity dot user data. I think as user data, then in wrap dot borrow. There you go. And then here you tell it which type you want, which is in this case entity. And there you go. It's gonna give you user data ref entity, and then we can clone it, which is fine here since entity is just copyable type. And there we go. We got it without having to actually implement user data on the entity. But that kind of sucks, so I'm probably gonna like do it that way anyways. But I guess let's see first of all if this actually works now. This should work, I believe. But for ergonomics, I'm probably gonna do it the other way. And there you go. Our new script works. Perfecto. Right, but honestly, nah, that's kind of sucks in terms of ergonomics. So let's just say struct Lua self. Lua self. And it would basically be just a wrapper type over entity, over a Bevy entity. and then we're gonna implement Lua user data for Lua self. And immediately we can actually drop that first part right here, where we actually have to create any user data and so on. We could just pass in, like, let's just remove this. And here right now I could actually just say Lua self entity, pretty much. Same thing in the other place where we're using the call function. There we go. Instead of Lua self right here. So instead of saying create any user data and so on, you just pass it directly because we have implemented the user data trait of mlua. All right, perfect. What else? Yeah, so the other thing is this part right here. Now you still cannot actually do this. You still cannot do this directly. It's gonna suck. It's not gonna work out. Like, if I actually count this out, it's still gonna have a problem. Unless if I'm wrong. Let's see. Expected entity found. Oh, sorry. Well, let's say .0. Let's see if this works. There you go. We're still, as you can see, we're gonna have a problem of from Lua multi. Now we could do the same exact thing as we did here, right? The entity and here Lua value, but that sucks, right? Let's do something better. So we're gonna implement Lua user data. No, Lua, well, what is it called? From Lua, okay, from Lua. From Lua for Lua self. Okay, and let's just implement this function here using the IDE, and then so basically here we're getting the Lua value and we're supposed to actually convert it into self, which is Lua self. Okay, so how are we gonna do it? Well, just like we have done earlier here manually, which is we're gonna say let entity is equal to value.as user data, right? And then in wrap, or can we actually do this? I'm not sure, but maybe borrow entity, or well, not really. In this case, it's basically Lua self, or basically self, right? So self. And apparently no, we cannot do this here, I think. Well, in fact, it's an option, not a result. So yeah, let's just inwrap. All right, and then borrow self. Well, the thing is, this could be another value than user data, so it could be something else. But right now, let's just inwrap. We're just crashing if the script is wrong. But anyways, borrow this user data immutably. And so after we borrow, we actually get a user data ref. Now let's actually clone it. Entity is copyable type, so it's trivial to copy. Well, we have to first to make sure that it actually derives that trait. Copy. And there we go. So now we got the Lua self. Perfect. We could actually return it as an OK value here. And there we go. It took me quite a long time to actually figure out how to do this. Some through the documentation, some through just experimenting, some through just like checking out the values and so on. But anyways, okay, cool. I think we're good now. Now we could actually just use Lua self itself as an argument to a function, right? Because we implemented from Lua. And the nice thing about this system is that it doesn't actually have to, like, basically this function right here that takes in the entity or Lua self, it doesn't really have to take Lua self itself. It can take any Lua type, right, as any Lua value, and then like if it's something else, we could do how, like, we could implement the conversion of it. For example, for an entity, we could like take, instead of a Lua, like instead of a light user data, maybe we could take a vector of two values, which includes the entity ID and the entity generation, and then we could convert that into a Bevy entity. But yeah, but for now this should work out, okay? And this should work the same, but right now instead of having to do that crap, we just say lua self directly, just like it's kind of like it's actually a real lua type. But yeah. Cargo R, there we go, perfect. Now to the next change that I want to do is, instead of actually having a rotate function in the world directly, I want to be able to get, okay, I see. I want to be able to get the like the actual components by name, right? So instead of this, I want to be able to say, let's see. So I guess local transform is equal to self. Oh, I can't get the component now through there now. Well, that kind of sucks, because it's just an entity. So I mean, I guess we have to say world get component or get transform self. Yeah. So you could say like this, or we could just say get component self comma transform. Right? And then we could actually check if it does have a transform. And then if the transform is there, we could say that transform.rotation. Well, not really transform. Well, transform is equal to transform rotate. So transform would be like an immutable thing. It's not going to be immutable. So transform rotate, and then you could use that. World rotate by, well, not rotate, set rotation. So set rotation, or set transform, or yeah, set component, actually, that's good. And then you could like say transform the new transform. Honestly, it did make the API a bit less ergonomic there. Yeah. What do you guys think? Should I merge the self and the world back? But then I'm not entirely sure how we're gonna implement the other way. But, well, world get components, get world get, so like you get the component. Now the transform could be in the object or it couldn't be, right? So basically it could exist or not. So it would give you either nil or an actual transform object, basically here, or sorry, transform component. Then you're gonna check if the transform is there in the objects. So if the transform component is there, then you could actually say transform, so is equal to transform rotate, and then you do your stuff on the transform. Then you set it back into the world. World set component self comma transform comma transform. Hold on a second. Why not just do it like this though? We could, like, we know the type at this point, I think, right? Yeah, we do know. We probably can get the type. So that's great. World get component self transform, and then transform equal transform rotate. The only problem with wait, well, yeah, that's fine actually. Yeah, I think that's pretty good API. local transform or get component self, comma transform. If transform, then transform equal transform rotate, and then world set component self transform. Yeah, let's actually try to implement this, honestly. Fine. Let's try to implement this. So how are we gonna do this? So in the world object, you're gonna need get component and set component. And by the way, set component, if the transform isn't there, like if the transform component is already there, then what it's gonna do is just gonna like overwrite it. If it's not there, it's actually gonna insert a new component called transform. I mean, yeah, let's try it. Let's go. I'm gonna sacrifice the ergonomics here for the sake of flexibility and safety. So, but anyways, mode RS, at least for now. All right, so how are we gonna do this? So we're not gonna have a rotate function anymore. We're gonna have a generic get component and set component function. Though we're gonna have that rotate in the transform itself, though. Yeah. Anyways, so how are we gonna do this? Okay. Now we're gonna have like a Lua transform wrapper over transform. Okay, perfect. Well, not really. Hold on, what the heck? Ooh. Yikes, that's interesting. Well, we could just make it generic over Lua value, I think. Yeah. Yeah, we could do that, yeah. Well, let's just see what's gonna happen there. I think I'm gonna need access to the Lua state here, right? And so this basically would need to return like a generic Lua user data because we don't know exactly what's gonna be the type. So here we're gonna match, well, instead of vector, we're gonna have as the name of the component. So it's gonna be like a string, right? Or we could say Lua string, I think. Well, just go with string, please. In fact, maybe we could just say stir, no? Can we do that? Not sure, probably. Match the name. Now, if the name is transform, actually, do we really need this stuff? Let's see. Here what we're gonna do is, I guess, okay, and then this dot world dot get transform, then we give it the entity, and then we clone it. Of course, we're gonna give a copy of the transform. Though we do have to say Lua transform. We haven't created that yet, but something like this. But we still have to make it into user data. So this is basically our transform, right? Let transform. Yeah, okay. Lua.create user data transform. Now let's actually implement that struct Lua transform here. there we go. The tree bound is not satisfied. So let's implement user data for that one. And there we go. Alrighty, Lua self. I don't think stir is actually, so then string. Yeah, okay, cool. And then we could say name as str. What's up? Non-exhaustive pattern makes sense. So if it's anything else, then we're gonna have a runtime error and known component. Cool. Well, let's actually remove this. Perfect. So okay, Lua, create user data, result any user data. Oh, well then I guess we don't even need the result then, maybe. Yeah, I guess so. So Lua, create user data, Lua transform. Well, we could just inline this. All right. There we go. That's monstrous. Can we make like a function helper for that? Let's see. Can the IDE do that? Extract, modify. No, hold on. Can the IDE do it automatically? So it's getting Lua and then this, which is mutable Lua world, and then entity Lua self. I mean, that seems about right. And then here we got the T transform. So that should be some T, right? Some generic. And maybe let's call this get Lua component. All right, and Oh, Lua transform, no. How are we gonna do that? They should have, I guess, EU value. Yeah, I mean, I can't think of a way right now to do it otherwise. Or you know what? We could do something interesting. Maybe. Man, let's just do it that way for now. Oh boy. Honestly, you know what? Let's not do this for now. Let's not overcomplicate things. Let's keep it in line for now. And yeah, copy paste until later on. Alright, so Lua transform, Lua user data. So this should pretty much work, yeah. Get transform entity in wrap. Yeah, right now let's actually implement the method of rotate on the transform. Implement default members. We don't need this register functions. We only need the fields and the methods. So let's start with the methods because that's what we need right now. And we're gonna have like a rotate method. So add method mutable, rotate this, and instead of this crap, we're gonna have a lua vector. Well, lua vector, yeah, pretty much. And then here, we're gonna say, well, what the heck? No, sorry. This is gonna be called a vector. And then this should be a lua vector. Is the stream fine, by the way? Yeah, perfect. All right, cool. So now we have a vector here. We could use Euler because it's way more ergonomic, though it is susceptible to what is it called? Gimbal locks. So you'd probably better use from angle, I think, or angle axis, I think, or something like that. From axis angle. You'd better use this one instead. But it's less intuitive and less beginner friendly. So for now, let's just go with from Euler. And then Euler Roch XYZ. And here you gotta say that though vector.x, I think like that, dot y, dot z. Perfect. And that, I think, should do the trick, really. I think that's maybe all we need for now, right? Oh, we only made git component. Oopsies. Can I actually make this method not mutable? I mean, it seems about right. It seems fine. Now, let's actually have set component. Is that what we need next? Let's see what the AI did here. Set component. This entity name, comma value. Lua value. Match name as sir. Transform. That transform is equal to value. Oh boy, we're gonna have to deal with that crap. Well, I think we could just say, maybe we could just say lua transform is equal to value dot into. Because we did implement that from, or into lua, I think, or whatever that is. No? Maybe it's something else then. Into lua performs the conversion. I think. No? Has incompatible types, cannot convert from mlua value. You know, just in wrap. That's not my, error handling is not my thing right now. Mismatch types, expected lua transform. Well, actually not into lua, from lua. Apparently, well, what the heck, hold on. So what did I implement there? Oh, I haven't implemented it for lua transform yet, I think. Yeah, apparently. So let's do that. Let's implement from lua here for lua transform. Alrighty, and then let's make this also clonable and copy. And there we go. It doesn't seem like we need lua here, neither here, and then neither, we do need this, at least for now. And what's next? Walaikum assalam GG Gear, and welcome to the live stream. How's it going? Welcome back. Now, can I actually say to lua or from lua or whichever? Apparently it doesn't seem like it. That's strange. So the value here is, I think, the value. Then lua. Can I actually do this? Can I do this? Okay. Cannot find value lua in this scope, which makes sense. And what's next? All right, that seems to work, I think. Yeah, that seems to work. Love that. But I do have to give it the type, right? Where do I give it the type? Can I give it there? Well, apparently I should give it there, right? All right, what's next? Now we got the transform. Get mute. So get mutable dot in wrap is equal, I guess, to transform dot 0, right? Is that the case? No. And valid left hand as well, I see. Well, actually not this. I want to say insert, really. Insert component. Well, I need to get entity mutable first. Well, entity mute. And then I'm going to get the entity, and then I'm going to insert my transform. Inject my transform. Perfect. I think that should work out. Yeah, I think I've implemented all the stuff that we're actually using right now in this script. Let's see if this works. It should be the exact same functionality, we just made the API more flexible and so on. Oh boy. Function update, cause, runtime, unknown component. Oh, I see. I see. Good question. So I know what's the problem here. Let's go back to mode RS. So the thing is about the transform, what is it called exactly? It's called transform like this. So let's actually do it like this. And I mean, we could maybe use possibly, yeah, maybe we could indeed use here a reflection of Bevy to automate this. Well, let's see. Cargo R, let's see if this works first of all. Oh boy. In known components once again. Where exactly? Well, what if I actually don't use the set component? I just want to know where the actual problem is coming from exactly. Is it get component or set component? Yeah, apparently the get component function for whatever reason. So, well, not here. So we're basically, oh yeah, I have not solved that there. Okay, interesting. I'm not sure though how world sick, I think, let's see if this works first of all. I mean, no errors. Okay, and what if I add this world set component? But like, how the heck that works? I don't think it would work out. Yeah, from nil to string. No. Okay, set component, because I haven't made some logic there yet, so it makes sense. Okay, so we have, oopsie, set component, there we go. So what we're doing here, well, the thing is, here we're actually trying to get the name. I mean, we don't really need a name, but if we do that, we have to actually try to convert that thing to a lot of types, which I think would suck. Yeah, no, let's just well, let me see what's up here. Value dot as user data. For sure it would be a user data, that's for sure. The next part is we have borrow, but we need to give it the type. We need to know the type. Call method chain. So this actually returns for us any user data. Whoops. Any user data, which is a value ref. Nah. I'm not sure how we can implement that, honestly. So yeah, let's just keep it as it is right now. Let's remove this stuff. And unfortunately, we actually do have to right now, for now at least, we have to do this. So like self, transform. Let's actually run now. It should work out now, I think. Oopsies, what's going on? Option in wrap on a non-value. Here. As user data. So apparently the value is not a user data that it took here. So we got the lua self, then we got the string, and then we got the value, which is correct, right? Lua self, we got the string, then the lua value. Is rotate actually doing the what we were expecting it to do? Let me see the rotate function. Is it returning the thing or no? No, it's not. That makes total sense. So we have to actually return it. Let's see now. Oopsies. What the heck? On a non-value again. Still here. Oh, rotate doesn't actually give us back anything. It mutates the thing. So that makes sense. So apparently you have to actually pass in this dot clone. Or can I just say this though? Yeah, I think so. Cargo R now. And we have a problem. The trait is not implemented for immutable Lua user Lua transform. Makes sense. Let's just say clone, yeah. And now it should work. Come on. There we go. So we got back to what we had working earlier, but now the API is extendable in some sense. Perfect. So we could also add fields here if you want to, like for, let's say, get the position. So fields, add fields, position, this dot translation dot vector. Are you sure about that? What? Type annotation needed. Huh. What does that even mean? I'm confused. Okay, hold on. What this takes? It takes a name and then a value v. Value v? Okay. So not a closure, right? Yeah, self. Oh boy, now I'm very confused. I don't have self here. This is confusing the heck out of me. Oh, this is static. Oh boy, that makes sense now. I was like, what? Do you think AI could replace us? Position, this. Do a transform, okay. Cannot initialize tuple structs which contains private fields. What the heck are you talking about? Oh, what? Ah, I see. I see. Well, then that means we have to say lua vector, maybe new. And then we can actually do that stuff. Though, is there like from array or something? Can we do just that? No? Expected vector found vec3. What? I see. Well, what if I actually made that as an array? Oh, there's no way to actually get it as an array. No, it just doesn't work that way, apparently. All right, let's just do it the Stone Age way. And there we go. Now let's go with rotation. We will need another custom type, but let's just go with scale for now. And let's actually remove this now because we're using it. So that's how you're gonna get the scale. Now if we actually come here and print, well, let's get the transform. So like local transform is equal to or to get component self transform. Now if transform, then we could just say print transform dot position and print transform dot scale. And this should work. Cargo R. Come on. And there we go. It actually does work. Cool. As you can see, it's actually printing the position first, then the scale. Position and scale. Which means it works. Now let's actually fix this. As you can see, it actually doesn't, like the LSP doesn't know what the heck is going on here. It's throwing out all these errors, which makes total sense. Because it doesn't have any clue what the heck is going on there. Right. So here, let's say get component. And the first thing first is the well, actually not the entity, the world. So like self world, comma entity, then the component name. And then the component could be, well, for now, let's just say, I guess, any. Does this work? Hold on. Let's reload and see. Failed to read different. Well, apparently I don't think I can do this. I think I just have to give it the type directly. I think. Let's reload again. Failed to read definition files. What the heck? Oh, my bad. What about now? Oh boy. Let me copy this guy, please, and let's go back to where we had what we had before. Okay, so this is what we had. All right. Oh boy. Okay, so get component like this. And maybe I could say this, I'm not sure, but let's find out. So this is going to be like self, actually, and then the entity. And then the string, it's going to be the name of the component. And then any for now, I guess. And then we could just remove this now. And let's try again, see if it doesn't fail this time. No, it didn't fail this time, which is amazing. So now get components actually works, as you can see. But the transform here, it's saying any because, well, I cannot really know what real type actually got there. Because, you know, string. So, or instead of that, and also we have to actually create a new class called transform, really. So declare class transform. And also let's actually make set components here. Set component, self world, then the entity, the name. It's not going to give you anything. And then I guess you give it the actual value, which is any. Right? So like the world, or yeah, the world, the entity, the name, then the actual value. Well, component, my bad. By the way, does it actually give the... Yeah, it does give the names, which is amazing. Perfect. Cool. So now here we have transform. So for transform, we have first of all fields. And how the heck do you do fields? Let's see. There we go. Just like Rust, interestingly. So you have to say position, which is going to be vector 3. I don't think you... Okay. And then the scale. And then finally a rotate function, which takes in the self as transform. And then a rotation vector 3, and then it gives you back a transform. And now that should be good to go. Let's reload the language server. And now it seems about right. Okay, so get component, you give it self, like world, then the entity, then the name string. And, or honestly, you know what? Let's just call this world instead of self. And then let's call this transform. Just so. And there we go. Perfect. Now we're getting what we want. Cool. Or like instead of any, we could also just like make a new type possibly, which is a union of multiple types. Now there's no examples of that here though, which sucks. But for now, at least, we could indeed just... You know what? No, let's just keep it like this. But you can actually do it yourself here. Like you could make this transform in Lua. And now the nice thing about this is that when you're gonna say transform, you're gonna have all like the actual auto completion and stuff, which is amazing. Perfect. Yeah, that looks perfect. Now we also need the rotation for the transform. Now the rotation, we're gonna actually need a custom type for that too. And before we go crazy here, let's actually make let's separate each one into its own thing. So like new folder here, and then I guess we're gonna have Lua objects, I guess, and then a new Lua mode.rs, which basically just gonna contain exports for those objects. And then finally, I guess let's start with the transform, for example. So transform.rs, and let's just take that. So this whole thing of transform, let's take it from here and put it here. Right, and then here we're gonna actually, well, first of all, we gotta make sure that this is public and this is public. And the other things maybe also public, I'm not sure. But anyways, let's right now just say pub use transform, Lua transform. And that's basically it. Now here, we can actually, where we have a problem, there we go. So control dot, oh. No. Well, let's actually add the module first. So module Lua objects, yeah. And now I think right now it would actually give me that option. So where's the, there we go. But it doesn't actually, it seems fine, apparently. That's strange. Oh, there you go, okay. Control dot, it still doesn't give me that option, what the heck? Well, let's just do it manually then. Use Lua objects, Lua transform, as simple as that. There we go. And cargo R. Pub use transform in Lua objects. What? Oh, we need to add it as a module, my bad. That makes sense. Module transform. Or instead of that, we could say pub mode transform, but it's fine, just say mode transform, do it like that. So we only export those. And now it should work out just fine. Okay, so what's the problem now? Oh, here, okay. Well, we're gonna need some imports apparently. Quick fix. Import. Well, just import all the Bevy preludes. And import all the mlua preludes. Is there anything else you need? Apparently not. We don't need these comments. Well, we don't need this comment either. And yeah, I think we're good. Cargo R, no Lua transform. Inscription plugin, Lua transform. What the heck? That's strange. Oopsies. Now what? This should work now, I think. Alright, so we separate the transform there. Perfect. Let's separate the other ones. Let's separate the other ones. So We have Lua world, Lua self. Oh boy. Lua world, I think I'm gonna put it in the module itself directly. Maybe not, no. Implement Lua world. Let's actually take this, put it near Lua world here, and let's actually go on. Take this and add a new module here, world.rs, add that there. And now let's go to transform, let's copy these preludes here, let's put them here, and let's go to mode.rs, mode world, and pub use world Lua world. Okay, so it's private. Let's make it public. And that's perfect, I think. Now we're gonna need Lua self and Lua transform. Super Lua transform, that's cool. And Lua self, we're gonna put it right now. So self.rs. Hopefully that wouldn't create any problems there. Like, let's actually see. So mode self. Yeah, I think it would make problems. Yeah, it is apparently. So let's actually rename this to Lua self. And let's say mode Lua self here. And then pub use Lua self, and we're gonna have that, and then where is Lua self? Well, not here. Here. Let's grab this Lua self from here. No boy, it's way cleaner right now, though there's still a lot of cleaning to do. So Lua self, and let's actually add those, and there we go. Perfect. So I think now we're good, right? Well, let's go to the world first, maybe, or well, Lua self is actually private apparently. Let's actually make it public first of all. Okay, now second of all, world rs. Let's actually do control dot import super Lua self, and we should be fine now with this. Oh, the field is private apparently. Okay, let's say public here. And now world is fine. Now here we need Lua self, and then we need Lua world. Is private quick fix? Well, no. That sucks. Okay. Public. And now I think we're good. Next up, I think maybe we could work on adding new entities to the world, like spawning new entities, maybe. Oh, but before that, let's actually continue on the transform. We have one more left, which is the rotation. Now that rotation is a quaternion. I mean, though we could actually go ahead and give the user just a Euler. Yeah, honestly, let's not worry about quaternions right now. let's just say fields.add field method get rotation. Let's just give it, or like give the user, let's see, this dot rotation, what is this, quaternion? And so we could say to Euler, I think, or something like that. Oops, Euler, yeah, there you go, to Euler. Then you give it Euler rot XYZ. And what's up, XYZ. That's nice, Rust syntax, love that. We're basically destructuring that. Oh, actually, yeah, actually does give it that. Okay, cool. All right, whichever. And what's next? So now we could also get the rotation. So like, this is the actual position, right? And, or, well, I don't think we could do that. Print scale. Well, before that though, or print rotation true. There you go. Now that should indeed work. Cargo R. And right now we should have rotation too. There we go. Perfect. Next up is what we want to do is, yeah, I said spawning objects into the world. How are we gonna do that? Good question. Good question. So we already have set components and get components, which is great. What we're gonna need next is somehow to spawn an entity into the world, an empty entity, and then the user could like set components. Yeah, pretty much. So how are we gonna do this? There is create entity here. No, that's too much stuff. So it's trying to tell me to do a table for components. And that's cool. For now, let's just make it create an empty entity. Let's not really bother. Add method mutable, probably. The name spawn. And finally the method. Now here what we're gonna do is, oh, I actually called it lua self. Maybe we should actually call that entity, yeah? Yep, exactly. Let's call it lua entity then. So f2 lua entity, right? And we can also rename this one here. Lua, well, just entity right now, yeah. Perfecto. Let's make sure everything is right. Yep, looking good. All right, cool. So here we're gonna say lua entity. And then here we're gonna say this dot world, I think. There you go. Dot spawn empty, I feel like. There you go. Is that it? Expected entity found entity world mute. I see. And I think we just cloned this, no? Huh. How do you actually use this? It gives me this. Oh, hold on, go back. So world entity get position in wrap. Spawn empty insert, then you get the I. Oh, okay, I see. So please give me the ID. And there we go. Perfect. Spawn. Or instead of spawn, we could say new entity. I think. And closure is expected to take 3 arguments. But it takes 2. Why? Oh, the arguments, right. Which we don't want any. Cool. Cool. Yep, perfect. So now what? New entity. Yeah, let's actually try it now. Let's see if we actually do it. So currently, if you see in the world inspector, how much like entities we have there. Come on. So this is the entities that we have currently. We have 1, 2, 3, 4, 5, 6, and only 1 irregular entity. So now if we come here into our script, hopefully right now what we could do is, let's see, world new entity. Right, so yeah, that's basically it. Let's try this out. And look, we're creating a new entity every frame. I forgot. Alright, cool. Love that. So it does actually work, apparently, which is nice. So let's actually do it in the start function. Let's say for I is equal to, I don't know, -5, 5, do, right? And then, well, let's actually say for x, and then here maybe for z is equal to -5 and so on, and okay, and then we would like have I called it create entity or new entity. Boy, where is it? Yeah, in the world. Okay, so new entity. All right, cool. New entity, and then basically what we're gonna do. So essentially what we want to do is world set component, and then here we want to do self comma transform comma. We could make actually an ergonomic version of this inside of Lua itself, right? So we could like make wrappers for those. Yeah, that's true. All right, cool. So world set component self, well, not self, the new entity. Then transform. Now here we need to create a new transform, but how the heck are we gonna do that? We haven't made that yet. So I think we're gonna do something similar to maybe vector. It would have like a global. Do we actually really want to do it that way? Yeah, I think that's good. Yep, let's see how we could do that. So, module, update script, blah, blah, blah. And basically, where we're creating the Lua state. There we go. So let globals is equal to state.lua.globals. Now globals.set function, I think. Well, set. The key would be transform. Now here the value would be a function. So state.lua.create function. .inwrap please, .inwrap. And here in the create function we need the closure. Alright, what's going on? Expected to take 2 arguments, pretty much. So Lua and then a what? Where f Lua and some parameters. So Lua what else? Could basically make it through a position and rotation for now, just to keep it very simple. Or we could instead do a table. Yeah, I feel like a table would be way better. Yeah. So let's say properties, right? Okay. And now those properties would be a Lua table. And then if let, well, first of all, let's construct the transform. It's going to be mutable. And now if let okay some position, what the heck happened there? Hold on. Something is wrong here. Transform constructor is equal to this. So what the heck is going on here? Okay. All right, cool. Now if let's position is equal to properties.get, well, not Lua table, Lua vector position, then what we're gonna do is transform.translation is equal to that. Mismatch types, oops, .inwrap I think here, no. Oh, here, my bad, I see. So, but hold on. Oh, it actually gives a result, I see. So we can say okay. So if we successfully got the position from the table, then we're good to go. Now if let okay rotation, same exact thing. And if let okay scale, same exact thing. Perfect. Perfect. I think we're good now. So maybe we could actually make use of it now. Let's see. Where is that? Well, hold on. Where's the script? There we go. So here we could actually say transform and then position xz. We don't need the scale. You could just keep it as the default value, right? And there you go. So you set whichever values and the rest would be the default values. And actually not like this, transform like this. Though honestly, yeah, it should be, since it's a component, then maybe it does make sense to do it like that, possibly. So let's actually go to, where is it? Oh boy, that's a lot of files. That's a lot of files. Transform like this. Alrighty. Now I think we could actually run this now. So world new entity, then world set component, entity transform, position vector. But yeah, as I said, we could make way more ergonomic ways of doing these things in Lua itself. And we have option in ramp on a non-value here for some reason. What the heck? What? Option in wrap on a non. Are you sure here? Here. Lua transform. How the heck did that happen? From Lua, so we're getting a Lua value that is not a transform essential. Oh, I think I know what's happening here. Yeah. I know exactly what's happening here. Let's go to Modaris. Here we go, and yeah, this always happens to me. Oh my god, Lua transform. Okay, sorry. Alrighty. So that should be good to go. And now we should have all those entities, as you can see, which have one component transform. As you can see, translation -5, -5, -5, -4, -5, -3, and so on. So it's basically a loop. There we go. So that works perfectly fine. Love that. Now we need somehow to actually attach a material and a mesh. Material and a mesh. I mean, that's what a PBR thing is. What PBR bundle, yeah? PBR bundle Rust. Is stream still alive? Seems to me. Alright, so we already got a transform. Perfect. And why the heck there is a global transform, I don't know. I mean, I know it is a global transform, but like why we have global transform and transform? Not entirely sure. Anyways, so mesh material and visibility and view visibility. User indication whether entity is visible. You could just leave that as inherited, really, at least for now. Inherited, whether or not entity is visible in the hierarchy should be also be false. Algorithmically computed indication whether entity is visible should be extracted for rendering. Ooh. But yeah, no, for now at least, what we really want is mesh and a way to add handles. Materials. So how are we gonna do that? Good question. So the thing is that I'm thinking about right now, at least, is world set component entity. Mesh. Then like you would have some sort of a mesh. Now the mesh would be we really need reflection, dude. I'm not entirely sure how are you gonna implement that. Well, actually, no. No. So you're basically gonna have local meshes equal to a table, and local materials is equal to a table. So you can basically keep track of them. Or instead of that, hold on. Actually, yeah, maybe. And then basically what we're gonna need first is to like say world add meshes. So add meshes, local, well, hold on. What the heck I'm talking about? Let's just remove this stuff, okay? And local meshes, add meshes. Oops. And now here we need to describe what kind of meshes we want. Or let's just start by one mesh for now. Fine. And for that, for now, let's just go with color, okay? Well, not really. This is a mesh, not material, my bad. Let me see the add mesh function. Where does it exist? I think in the asset server. No? Why it doesn't... What? Hold on. Let's go here, main. So meshes.add. Oh, okay. So meshes. Res mute acts assets mesh. So basically assets. Then we got the add function. Import into an asset. So let's see the mesh asset. Mesh asset. Huh. Hold on. Actually, let's go back to asset. Well, there we go. Is there like a mesh here? No, but is there like an asset? Let's see. There we go. So who's implementing it? Is there a mesh here? There we go. For mesh. 3D objects made of vertices. Mesh new. boy. I think maybe we don't even need the material for now. Probably would add like a placeholder or something. But yeah. Okay, but how do we make those? We use a cuboid, which is like primitive, Bevy math primitive, dem 3D. Bevy math primitives. Bevy math well, let's just look for primitives. There we go. And we have all these primitives that we could actually use essentially. Okay. And one of them is a cuboid, right? Correct. Now this cuboid takes a half size as a vector 3. For now, let's just support primitives. So it would be half size vector 3. Okay, so how I'm gonna do this now? Add the mesh. Primitives dot cube something. And then like you would have a vector. Type cube half size. Well, here actually would be a cuboid. Half size vector. Yeah, I think that would basically be it. World add mesh, primitive, type and half size. And then after that, after you get the mesh, you could actually add it as a component. So in fact, at least in this case, well no, we don't have to add it like for every entity here. We have to add it only once and then reuse it. Right. And coming to think about it, we could just make an API instead where we have like world set components. And then like you would say the entity is equal to, well, entity, and then transform is equal to that, then mesh, yeah, and then you wouldn't need any of these. Right. So now I have to implement add mesh and then the primitive here, and then change the signature set components. Oh man. So this would become world set components entity self and transform. Pretty much. Now the only problem with this way is that we're gonna lose entirely the actual signature, like types, so on, which sucks. Though, well, we may be able to do something about that actually. We're using the type system, but yeah, whatever. All right, let's first of all change the set components function here. And then honestly, after this, I think I'm gonna end the stream. Well, let's see. All right, so where is it? Set components, okay. So now instead of lua value, you would actually get a lua table. In fact, not like even string and lua value, let's remove those. Instead, well, even lua entity actually, yeah, true. So yeah, that means we're just gonna take a lua table here, and these are like the properties, right? And then we're gonna extract here the entity first of all from the table. And what the heck is wrong with you? I see what's wrong with you. Let's actually add this, that, oopsies, and I guess add this. Yeah. And now here we need the name. Now, like for the rest of those properties, so yeah, let's actually do this. And now properties for each key comma value. If key equal to entity, we're gonna ignore it. Otherwise, do that. Mismatch types, expected enum result, found unit type. What do you mean? Maybe you mean here? Okay, cool. So key should be a string, and the value could be any lua value. So if key equal to entity, then we're gonna return okay. And return type preferred to be, well, no. It's gonna be, well, nothing. True, at least for now. So yeah, we're just gonna return pretty much, that means. Actually, no, result, well. Well, not really return, well. Oh boy, I'm very confused right now. Let's just say return. Let's remove this stuff. Remove this. And my brain is zoning out at this point. For each function, it's going to give a result. Fn mute. Can't I just actually continue or something? No, that doesn't make sense. Okay. Yeah, that seems about right, actually. That seems about right. Now, the next thing is we're going to need a global, or actually not a global function, add mesh, yeah. Well, that's not what I meant. I meant to actually add it as a resource. So, but hold on, what the heck, hold on. What we have here, so add mesh, and then you basically should give it like, I guess maybe a handle. Well, what a primitive actually gives you. So like cuboid, it gives you a cuboid, and then you can, what? How? I guess maybe it implements into. Maybe it implements into. I mean, if we go to add meshes, oh man. Lua entity test.world.spawn empty. No. I'll just say okay for now here. And well, let's go. And now we need to get the asset server. Not the, is it really? I see. Exactly. So get resource assets mesh, and then we're gonna add, so assets.add, and now here this actually takes anything that implements into A into an asset. But how the heck can we? Well, for now, I guess maybe it'll just take like a primitive object. So here it's actually saying mesh from cube. That's interesting. Whoops. So here we got the mesh. It's gonna be like a Lua mesh maybe. Yeah. Add method mutable. So let's create a struct Lua mesh, which gonna do that, and then impl Lua user data for Lua mesh. Nimble from Lua for Lua mesh. Oh, we could already do that, huh? Meh. Meh. Let's just treat it as an opaque type. Where is that thing? Alright, here we go. Okay, so I'm just gonna copy this. Go to here real quick. Put it here. There we go. Oh, we have to actually be able to clone that. A mesh, you really do not want to clone that. That's huge, I guess. So like, well, actually, yeah, I mean, it does contain a lot of crap. Like, you're gonna allocate B-tree map, you're gonna allocate, what is indices? Option. Yeah, it does contain a lot of stuff, honestly, so no. So for that, we're actually gonna go with an RC, I think, or, yeah, RC. But I think that wouldn't allow me to mutate it, so I guess we're also gonna need that ref cell there. So RC ref cell import. C ref cell. So basically, when you actually clone this now, you wouldn't clone the whole thing, you would just clone the reference. So we would get a second handle to the thing, basically. Now add mesh. He's not satisfied. Add mesh.0. Can I just do that maybe? Trait bound. Yeah. I have to either, well, can this, what this can take? Can it take like a borrow? I don't think. I think we should just like take the whole value out of there. At that point, maybe. Or maybe we have to clone it. I mean, can we take it though? I don't think we can. We have to make it an option. Well, good question. Let's just keep it as a clone for now. Alright, whichever. So now we gotta add mesh function, which should remove this from the equation. We already handled set components. Now the next thing is a primitive global function, which would create that cuboid. Okay, oh boy, I'm dying. Let's see. Let primitive constructor. And what the heck is this AI trying to do here? Alright. So please get a table. Do a table. Now what we got here, well, no. Alright, let's get the name of the primitive. Properties get string name in wrap. And then we're gonna go through all the other fields. So if key is equal to name, is it called name? Actually, it's called type in this case. Or I mean, we could call it name. Let's just go type, fine. Oh my. So match name. Actually, no, we don't want to do it this way. Remove this stuff. Just say match name, Esther. Now, in our case, you would only have a cuboid for now. A known primitive. Perfect. Now, I don't know why it's trying to do this, but we're gonna get the half size here from the properties. And then we're gonna try to create this cuboid thing. Well, that's not the way you do it. Let's say cuboid from, oh, so apparently we can actually just get the size, so fine. Let's just go with size, or honestly, nah, let's just, I guess we could just say this, half size. Is that okay? Well, I see. Oh, okay. Half size. The half size is equal to that. And there we go. Now, okay. Mesh. But I think we're gonna have a problem there now. Into Lua multi is not satisfied. Well, that makes sense because we have to use our new Lua mesh thing. But I think it's probably private at this point. So let's make it public. I'm gonna make this into its own file in a second. But for now, this should work. What the heck, type of struct isn't accessible. Ah, I see. So then public use world Lua mesh. Alrighty. Now here we go. Should be accessible right now. Import. And oh, we need the RC stuff. Okay. Well, then let's not make this public and let's just implement new. Exactly. And there we go. Now let's go back here and say Lua mesh new. Oh boy. Let's just say this. And there we go. Now what's wrong with you? Oh, RC ref cell cannot send between threads safely. Interesting. So I guess then we need an arc. But then if we need an arc, we're gonna need them freaking mutex here. Oh man. How's that? That's interesting. So we cannot have ref cell here either. So let's go with the RW lock then. Now here, RW lock. Okay. Now is everything okay here? There we go. And what else? I think we're good there, probably. Yikes. Now to find out, I guess time to find out if this works. Probably not the first time. No method named borrow found for struct in the current scope. Well, read in wrap.clone. The trait bound is not satisfied. Oh. Well, here we're actually gonna get a lua mesh. And oh boy. No, we don't want this here. Well, actually we do want that, yeah. Let's remove this. Add mesh. Cannot borrow edges behind the reference. Huh. Get resource mutable, I guess. Right. Oh, what? Change it to be mutable. Okay. I do think I'm missing something, probably the components. I gotta add the new entry there, I feel like. But we'll see about that in a second. Okay, in function start, attempt to call missing method new entity. What? Attempt to call in line 18, I guess in here. World new entity. A missing method. What do you mean by missing for real? Attempt to call missing method, flow world. I'm pretty sure I have new entity function there, come on. Oh. Where the heck was it gone? Ah, I think I removed it by accident. What? Ah, man. This is wild. I don't know how did I remove that. Ba. Let's add it back. New entity. This method takes one argument, but as your arguments were supplied. Okay, now all right, cool. Next step, I think I know what's happening there. Actually, I don't. What the heck? Remove non-send resource. But before that, okay, in function start, and known component. Yep, exactly. I know what's going on. So right now in here we have a mesh component. We haven't added that yet. So let's go to our world, and in the set components function, we need that. So we need to add mesh. So we're gonna get a lua mesh, and then what the heck is going on here? Entity mute, insert mesh 0 in wrap. What do you freaking mean, dude? Come on. It's not implemented for Bevy prelude mesh. Well, actually, yeah. You need actually a handle here, really. And in fact, that's crazy. You need a handle. So what add mesh gives us? I think it does gives us a handle. No? Hold on. What the heck is happening here? Alright, add mesh. What it gives? Assets, add. Oh yeah. So, I see. So we're supposed to have something like this, but of course this wouldn't really work out. Yes. Because we have to have another one now. Called, so this could derive clone, I think. Abstract lua mesh handle. And then what? Import lua user data for lua mesh handle. Yeah, is this okay? I don't think that's okay. Let's make sure to implement this too. For the lua mesh handle. And now instead of lua mesh, we could say lua mesh handle, and here we could use it to wrap that, and That should do the trick, maybe. I think you just insert mesh. No? Lua mesh. Oh, mesh.0. That seems about right. Yeah. Okay. So does that work now? I don't know. Let's go back to rotation.lua. Set components, entity transform mesh. Okay, so where's my Lua file? So this should be like this, at least for now, and this transform. Now let's see if this works. Unknown component. Huh. Can you give me more information, please? Let's go back to set components, and instead of just this, let's really do some more stuff here. Format unknown component, please. And there we go. And no component transform. Oh. So apparently here. Right now we have all those meshes, and okay, cool. We have a handle to a mesh. Perfecto. Perfecto. But I think we need the visibility too there. Maybe. So for now, let's just hard code this because I'm just too. Let's see. So after we add the mesh. Or fine, just keep it like that. Now let's add some other stuff real quick, just as hard coding, please. So I guess we're gonna need visibility probably, and hopefully the default value is actually on. Inherited, okay. And let's see if that helps. Oh. I mean, I don't see anything. So maybe I do need the material too. Well. Oh boy. Is there like a default material or something? I don't think I could insert a whole bundle. I mean, I could just patch it right now. Yeah, I could just patch it for now, just hard code stuff real quick. So first of all, let's grab the transform out of the mesh there. Thank you. And now let's actually we got the Lua mesh handle. Now we need to actually add some material. Mute materials, get resource mute. And now materials.add standard material. Now this is super bad, but should work. Let material. Right, so now we got both. Then hopefully right now we could just do this. Insert bundle. I'm not sure if it does accept a bundle as a, because if not, that's gonna suck. I guess it does. Yeah, it does look like it. But if it really does, I don't know. Now this is very bad, because like we're making a whole resource for every one of these. But I just wanted to hard code it so we could see if this works. And it does actually work, apparently, which is amazing. Now we could make this smaller. So we can see the individual cubes. And there we go. Perfect. Let's set the y to a math.random. I guess from -1.0 to 1.0. And there we go. All right, power scripting. There we go. So basically right now we just need to add a way to actually add materials in Lua. And then we should have quite a little working product to some degree. That's pretty cool. That's pretty cool. Though we don't actually have a way to iterate through all the entities yet. That would also be useful. Oh man, there's just a lot of things that I'd like to add. But you know what, I'm too tired at this point, I'm not gonna lie. So, you know what, for now at least, I'm just gonna add a comment here. Where is it? To do add material to the scripting API. Instead, hard coding it here. Right, and we also want to add some other stuff. But yeah, that was it, I think, for the stream. I'm too tired at this point. Yeah, that's pretty cool stuff. I don't think the material is actually shared here because we're making a separate material for each one of those. Yeah. There you go, look at that. So each one of those actually have a separate material right now, which sucks for efficiency. But yeah. Anyways, that was it guys for this video. Thank you, or for the stream. Thank you all for coming in. Thanks for Loop Luminary, Hats, Gandev, Theo Paris, and Woji Kieran. Thank you all for tuning in, and see you later. Goodbye everyone.